Good. So, hi, my name is Ivy, and I am a student from Chen High School in the US. And today I'll be talking about an intelligent lock system to improve learning efficiencies using artificial intelligence and Internet of Things. So think about the last time you went to a conference or family gathering. Didn't most people always have their phone out, even if the most interesting conference speaker and beloved people are right next to you? Addiction to phone usage has grown to a global problem faced by both male and female, young and old. Estimate shows that 80% of the people with smartphone spend a large proportion of their time on screen-based activities. Smartphone addiction is caused by internet overuse or addiction problem known as nomophobia. A study done in 2012 said that in 2018, nomophobia will grow from 53% to 66%. However, things are getting a lot worse in the year of 2022. The coronavirus pandemic forced people to stay indoor, make us more attracted to our electronic devices. So as you can see in this picture, according to the smartphone addiction poll, 99.2% of the user experience fear and anxiety if they don't have their phone, indicating nomophobia. And 37% of the 99.2% have mild nomophobia, 50% have moderate, and 13% have severe symptom of nomophobia. So nomophobia can lead to symptoms like depression, rapid heart rate, increased blood pressure, anxiety, and many more. So knowing the severe cost of overusing cell phones, there is a need to start taking action to prevent phone addiction. So before you start assuming my devices are similar to the existing ones like do not disturb mode, silencing phone's notification, deleting the apps, and there's also mobile application like focus timer and set time limit for certain apps. Let me explain why my idea is unique. So all of the techniques used to prevent phone addiction can have an easy counter method that undo the whole purpose. User can easily turn the notification back on, reinstall the deleted app. The methods are therefore temporary and do not result in any lasting effects. The common problem shared among all these solutions is that the phone is in the user's hand, thus they can easily modify the setting anytime they want. And there's also a common method to prevent phone addiction will be manpower. So parents often grant their children from their cell phone or physically seizing their phones or set like a time limit for the kids to use their phone. So despite them not having their phone, the teenagers are still not productive. As a young adult, many teenagers desires independence. They wish to gain freedom from the rules set by their parents, despite lacking the skills to support themselves. Therefore, simply taking their phone away leads to reverse effects and in severe case will worsen the parents and children relationship. So noting a need for a solution, I created a new idea, which is a physical phone cage. It will be a physical feature of a jail cell for electronic devices and a mobile application associated with it. The proposal method will allow users to lock their phone in a cage within a reasonable set time using the associated app. The method effectively resolves the problem on phone addiction. So the phone cage unique physical feature is the ability to lock the phone, making it inaccessible for a set time of period. Once the user places their device into the cage and start a timer, the cage will only open when the timer goes off. This prevents users from getting distracted in the middle of their work or the study as they cannot pause the lock time. The idea provides a long-lasting counter for overusing phone. The phone cage gives user freedom, but to a certain extent. Thanks to the self-set timer feature, teenager no longer needs parents to enforce passive rule onto them. Instead, they can actively choose to lock their phone away and decide how long to lock for. This will train teenagers to decrease their dependence on electronic devices without causing issues. Phone cage does not have any age limit, so anyone from the age group can access to this tool and have the ability to use it. It aims to promote productive population. So I start off my project with some research on related works. So I got my inspiration So I got my inspiration from an Internet of Things smart locker. So this locker is used as a safe personal item. So I got my inspiration to do like a box with microserver controller. However, the project is more about security. So they have scanner and door lock system. But I want to do something that's able to lock the phone for a time period. The Internet of Things smart locker can be opened anytime they want by fingerprint, but I wanted the cage not be open at all until the timer goes to 0. So I decided to use an application associated with the phone cage. So I started my physical phone cage by an online 3D modeling program called Tinkercad. After finishing designing the cage, I used the 3D printer and print out the cage and the sliding lock. So this step was actually done over and over again in order to get the perfect size and thickness of the cage and the feeling for the printer. Then I created a mobile application, as I said, using Thunkable. So in this app, the user can set the amount of time in the phone by using a slide bar. When the user clicks on the lock button, the timer will start and there's no way to stop the timer. The cage will only open until the timer goes to 0. So after that, we connect and save our data to the Firebase real-time database. So the Firebase is linked to the Thunkable, checking the timer, timestamp, unlock time, and if the phone cage is locked or not. When the screen starts on the phone cage app, it will get the Firebase data from the Firebase real-time database. So when the user first clicks on the start button on the mobile app, the app will change and update the Firebase real-time database. So it will display the lock variable to true, the timer to the timer's value times 60, the timestamp to the current time, and the unlock time to the slider's value plus the current timestamp. So lastly, I use a Raspberry Pi Zero for my project. It is used to control the microserver and the length of the pulse. So the microserver arm will turn at an angle to control the slide lock on the cage. So I'll first take the pin 18 to the pulse width modulation. After setting the correct mode for pin 18, it will give a clock to show how long the square wave will be. So I first create a function called lock up phone and input of lock time. So I write the pin 18 and give it a pulse which corresponds to the angle. In the code, the 50 and 125 is the length of pulse. From 50 to 150, the microserver arm will slowly increase the angle over time from opening and closing at a speed of 1. So as you can see in this picture, the left side is the real-time database. It checks for lock, timer, timestamp, and unlock time. And the right side is the Raspberry Pi connected to the microserver. And the red circle that I circled is the microserver arm, and it's basically about turn the angle and controlling the lock. And this is a demonstration. Is a physical. And this is an overall diagram of my procedures. As you can see, I created the Focus app by Thunkable, and the app is connected to the database, and so is the phone cage, which is the Raspberry Pi. So to evaluate the success of my application, I used 2 different experiments. The first experiment tests the function of the application by doing repeat testing, and experiment 2 proves the success of decreased smartphone use by using a real-life experience. So the first experiment was conducted by testing the phone cage 50 times. We put my phone into the phone cage and lock it for 1 to 5 minutes. We then record how long the phone is locked, and the result is in the spreadsheet listed below. As a result, during the 50 times testing, the phone cage was working as expected, and we tried different length in the lock time, and each time the phone remained locked until the timer hits 0. So this experiment proves the application functions correctly. The second experiment was conducted by giving my phone cage project to 10 randomly selected sample users from a high school. So we first recorded the average time they need to work on homework each day after school and the quality of their work. After a week of using phone cage each time, we surveyed each user again through their work time and whether the quality of their work increased, decreased, or remained the same. So statistics shows that 80% of the user indicates a decrease in their average work time. Of those, 50 indicates a dramatic increase in efficiencies as their work time decreased by more than a third of their usual work time. And also further surveys also shows that 70% of the sample users believes that their work quality increased after using the phone cage. The increase in quality could be demonstrated by few missed problems and higher performance in exam. And according to my own statistic, 8 out of the 10 sample users, we randomly selected indicate decrease in their average work time. So this number of users admitting positive outcome using our phone cage exceed our expectation. We were confident that at least 50% of the sample would find phone cage useful. Our data not only support but also extend the expectation. Of the 8 that admit a decrease in their average work time, 50 indicates a dramatic increase. This shows the success of our phone cage to a greater extent. The sizable decrease in work time proves our point about people wasting time on meaningless electronic devices. So locking away phone at specific time truly boosts our samples user working effectively. So finding from our data agree with our central idea of decreasing the use of phone to increase people's ability to concentrate, thus producing better work at shorter times. So the two experiments prove that the phone cage is a reliable tool for the user, and this project is therefore significant to the community since it is able to use a fun way for parents to restrict their children and allow children to focus on important activities such as homework and bonding with family. So to sum up my presentation, the phone cage is designed to help children's family, teenagers, student, and even adult to let them work productively by limiting the use of electronic devices. So right now there are some limitations of my project. First, since it is like a physical phone cage, it is not as portable as those digital apps. And also right now the user have to basically carry the physical phone cage and with the app in order to make this project work. And also right now there's only one feature of my app. Instead of just having a simple timer, I hope to create more interesting tasks. So if the student finished writing 100 words on their essay, the box will unlock. And for the physical box, I was thinking instead of just having a 3D printer box, maybe we can add more tools like portable charger. So instead of just simply putting the phone into the cage, they can charge and lock the phone at the same time. And this is my references. Thank you for listening.